let's see if we can, this is number 9 on paper 1. Paper 1. And you're trying to show that the tangents are the same. Let's do the slopes first, because this is actually quite lengthy. I would rewrite this. This is typical for IB. If you don't make this creative leap or this step first, you're probably going to be a little bit lost. Change that into the product of two functions. Then it's a little bit easier. How do you take the derivative of two functions? Product rule, right? So you'll have hi-ho. Remember that? So you go e to the x times the derivative of e to the y is e to the y times what? dy dx. Very good. Plus e to the y times what's the derivative of e to the x? E to the x. Okay, on this side, we're going to do a chain rule. So the chain rule is center of the Tootsie Pop stays the same. What's the derivative of cosine? Negative sine. Center of the Tootsie Pop stays the same. But we're going to take the derivative of the inside, xy, which is a little baby hi-ho. Just a tiny one. So it's x dy dx plus y times 1. And the reason that's important is because you're going to multiply these out to get two separate terms. Wouldn't it be tempting to say this is just negative sine like y, or even y d, maybe x dy dx or something silly like that? You got to do the whole hidey-ho with that. So now I'm going to get e to the x, e to the y, dy dx. And then I'm going to multiply these two together, which is x, negative x sine xy dy dx minus y sine xy. That's what happens when I multiply those together. I'm going to move this over to this side. So I'm going to get plus x sine xy dy dx. And then on the other side, I'm going to keep this minus y sine xy, and I'm going to move this one over to the other side. So you get negative e to the x, e to the y. So notice that all the terms that had dy dx's are on one side. All the ones that don't have dy dx's are on the other side. Any questions so far?
Are we solving for dy dx?
Yes, that's our goal. So I'm going to do that right now. Dy dx times e to the x, e to the y, plus x sine xy equal to negative e to the, I'm going to call it e to the x plus y, minus y sine xy. Then I can solve for dy dx. And this is not my answer, but it's really close. Over this thing, e to the x plus y plus x sine xy. What do you think? Are you okay with how I solve for dy dx? So this is called an implicit derivative. Because you have x's and y's, you're going to have more than one dy dx term, so you combine them into one, and then solve for dy dx, which I did here. So now we're going to analyze the slope for the two different points. The first one is 0, 0, my favorite. Dy dx is equal to negative e to the 0 plus 0 minus 0 times the sine of 0 times 0 over e to the 0 plus 0 times sine of 0 times 0. Well, all of this is going to be 0. All of this is going to be 0. So you're going to end up with negative e to the 0 over e to the 0, which is negative 1. That's the slope for that one. Good so far? You feeling smart? Yeah, I think so. So now we do the same thing with is it positive square root of 2 pi, comma, negative square root of 2 pi. That's my point there. Now, this doesn't look possible that it's going to be the same, but it is. Negative e to the square root of 2 pi minus square root of 2 pi. What's that going to turn into? 0. Then you get, with this one, you're going to get negative square root of 2 pi times the sine of the product of the square root of 2 pi times negative square root of 2 pi, which is going to be what? Negative 2 pi. And on your unit circle, is negative 2 pi the same as 2 pi? Just the way the circle is, it's the same thing. So what is the sine of 2 pi? 0. Sine is 0. So this thing is going to go to 0, not because of the square root of 2 pi in the coefficient, but because of the sine of 2 pi. And then in the bottom, you're also going to have e to the square root of 2 pi minus square root of 2 pi. There's going to be 0 again, plus x square root of 2 pi times the sine will be negative 2 pi again. So this one's going to go to 0. And what you're left with is dy dx equal to negative e to the 0 over e to the 0, because all these are 0, and you get negative 1. So what did I prove? I proved that the slopes are equal, and that is good. That's great. We proved the slopes were equal. Go back to the problem, though. It is worth 7 marks. It says they have a common tangent. What else do we probably need to evaluate other than... Is that what they had on the answers? Yeah. I would maybe even double check y equal mx plus b. You may need to know what the b is. So for the first one, 0 equal to negative 1 times 0 plus b. What's b equal to? 0. For the other one, y equal to mx plus b. Y was negative square root of 2 pi. The slope is negative 1. X is square root of 2 pi plus b. What do you notice that b is going to be this time? 0. So since the b's are the same and the slopes are the same, your tangent lines will be the same. So there's your common tangent line, slope and line.